review a little geometry things that are just things we should know. The first thing is the sum of all the angles in a triangle add up to be what? Y'all remember?
180.
That's right. All angles add to be 180 degrees. All right. Something else about triangles. If we have a right triangle, the longest side, which is the side across from the 90 degrees, from the 90-degree angles, is called the hypotenuse. Y'all remember that word? All right. And it's always across from the 90-degree angles. Hypotenuse. I had to sound it out. And the third thing we need to remember about triangles is something called the Pythagorean theorem. And the Pythagorean theorem says if you have a right triangle, the formal definition says the sum of the squares of the legs of the right triangle are equal to the square of the hypotenuse. In other words, known as a squared plus
b squared equals c squared.
Very good. And A and B are the legs of this triangle, and C is the hypotenuse. So let's just talk about what I'm talking about when I say legs. You got a right triangle. A right triangle has a right angle, which is 90 degrees. So the two sides that form the 90-degree angle are called the legs. So this is a leg, this is a leg. And the side across from the 90-degree angle is called the hypotenuse. I can't spell. Hypotenuse. Hypotenuse. Okay, hypotenuse. All right. So we're going to talk about trigonometry, and we did a little bit of this in geometry. We just didn't talk about the inverse functions very much, or my class didn't anyways. You might have if your teacher was more thorough than me. It's very possible that happened. So, also if we have a right triangle, I'm just going to draw a basic one like this. Basic right triangle. So here's our angle down here that we're talking about. We're going to call it theta. Now, theta is a Greek letter, and it basically looks like an oval with a line through it. We had sigma. So theta is another Greek symbol, okay? But it is used often in trigonometry to represent angle measures. So it's just a little oval with a line through it. So if we have our angle down here, then hypotenuse is going to stay the hypotenuse. It's the one across from the 90-degree angles. If I could spell hypotenuse today, it would be great. Hypotenuse. All right. The leg, you got two legs also. The leg that touches angle theta is called adjacent. Adjacent means beside it. So the one that touches the angle theta is called adjacent. The one that does not touch angle theta is called the opposite. So depending on where your angle is, you have an opposite leg and an adjacent leg, and the hypotenuse is still the hypotenuse. All right, so we have 6 trigonometric functions for an angle. I know, isn't that funny? Don't we sound smart saying trigonometric?
So what does mu alpha theta?
We're not talking about that, but it means letter mu, letter alpha, letter theta. And it's a mathematical association of something is what it stands for. But that's it. Math likes to use a lot of variables that are green. Because a lot of discovery of mathematics happened with the Greeks. Like around Bible times. Yep, back in the Bible days. Trigonometric. Say that, trigonometric. It just rolls out of the trigonometric. Very good. All right, so we have 6 of them. We have one called sine. I know it says sin, but you say sine. You got one that says cosine. I know it says cos, but it's called cosine. And you've got one that's called tangent. And we know we say it is written tan, but it's tangent. Anyways. And then we have inverse functions called cosecant, secant, and cotangent. Yes, cosecant, secant, and cotangent. Now, for sine, cosine, and tangent, you might have learned the phrase in geometry, SOHCAHTOA. SOHCAHTOA. Raise your hand if you've ever heard of SOHCAHTOA. You probably did. All right. There's another teacher that before has said Oscar had a heap of apples. That works, but I like it better SOHCAHTOA because this tells me that these two go with sine, these two go with cosine, and these two go with tangent. So I like SOHCAHTOA better personally. But there's other teachers that have other ways to remember them. So sine of theta comes from the SO part, is going to be opposite over the hypotenuse. So you take the opposite of that angle and put it over the hypotenuse for the sides of the outside. Cosine is going to be adjacent over hypotenuse. That's why it's CAH, adjacent over hypotenuse. So what do you think tangent's going to be?
Opposite over adjacent.
Opposite over adjacent. Okay. So you can get SOHCAHTOA to get you sine, cosine, and tangent. Okay? Well, these little nice ones are called inverse trig functions. Okay? Cosecant, secant, and cotangent. Cosecant means the inverse of sine. That means the inverse of sine. So that means you take sine and you write down the result.
How about the opposite?
Absolutely. So cosine or cosecant means, I'm going to write that it's sine inverse, is going to be hypotenuse over opposite. Secant is the inverse of cosine. If I can write what, my hand is not writing what I want it to do today. Of theta. So what do you think secant's going to be?
Tangent.
No, there is.
Adjacent over opposite.
No.
Hypotenuse over there.
Yes, it's the opposite of cosine. And then cotangent is the inverse of tangent, which is adjacent over opposite. Okay? That makes sense? So you can do SOHCAHTOA to get your sine, cosine, and tangent, and these are just the inverses. Cosecant is the same thing as inverse of sine. Secant is the same thing as inverse of cosine. Cotangent is the same thing as inverse of tangent. All right. So here's some examples. It's going to say evaluate the 6 trig functions. If I say trig, that means trigonometry. Of the angle theta. All right. The 6 trig functions of angle theta, and here's our triangle. And y'all know my handwriting, my drawing is wonderful. All right. I'm being sarcastic. Here's theta. This leg is 24, and this leg is 7. Obviously, this triangle is not drawn to scale, right? Right? Why can I tell this drawing is not drawn to scale?
Because 7 is longer.
Yeah, because it looks like 7 is longer than 24. They're not even close to each other. Okay. So my 6 trig functions will be sine theta, cosine theta, and tangent theta. And then I've got cosecant theta, secant theta, and cotangent theta. And remember SOHCAHTOA. So sine theta is going to be what over what? Sine is what over what? Opposite over hypotenuse. Now, we don't have the what? We don't have the what in our triangle? Hypotenuse. Can we get our hypotenuse?
Yeah.
Using the what?
A squared minus B squared.
Plus. You're right. So to get the hypotenuse, if I can write, seriously, my hand's not right when I want it to today. A squared plus B squared equals. So we're going to say 24 squared plus 7 squared equals. Can somebody tell me what 24 squared is? 576. Plus what is 7 squared? And what is 576 plus 49?
625.
Perfect. And then the square root of both sides. What's the square root of 625? 25. So my hypotenuse is 25. And I had to find that, didn't I? So before I can find the sine, I had to find hypotenuse. And I did a squared plus b squared to get that. Does that make sense? Okay. So sine theta is going to be opposite over hypotenuse. Now here's theta down here in this corner. Which one is opposite from theta? That means it don't touch it.
The 7.
The 7 is opposite. I'm going to put an O by 7. Okay? So 24 is the what? Adjacent. And 25 is the hypotenuse, right? You can always pick out the hypotenuse because it's across from the 90-degree angle. Always, always, always. All right? So opposite over hypotenuse will be 7 over 25. Is everybody good with that? So we can go ahead and do cosecant. What's the inverse of that? 25 over 7. Does that make sense? So if I can do sine, I'll do the reciprocal and I get cosecant. Right? Cosine, co, is adjacent over hypotenuse. So which one's adjacent? Over. What's the hypotenuse? 25. So secant's going to be what? 25 over 24. Does that make sense? And then tangent is what over what? TOA. Opposite over adjacent, so that's 7 over 24. So what's cotangent going to be? 24 over 7. Haha, 24/7. Isn't that funny? So that's how you do it. So if you have to find the 6 trigonometric functions, that's how you do it. Any questions? If you have to find the hypotenuse, do a squared plus b squared equals c squared. Got it? Not even close. All right. Next example. I don't care. Let's theta be an acute angle. What does acute mean? It means less than 90 degrees. So theta is an acute angle of a triangle. Find the other 5 trig functions. Yeah. Of theta if cosine of theta is 3/8. And they tell me that's all they give me. They don't show me the picture of the triangle, but they tell me that cosine of theta is 3/8 and 3 is an acute angle in a right triangle. So what I would do, I would draw a picture. All right, so draw a right triangle. Put me a 90-degree angle and put me a theta somewhere. Now, cosine is what over what?
Oh, opposite over.
Not opposite. So, so this is my adjacent, this is my hypotenuse, right? So when I'm drawing my picture over here, the hypotenuse is across from the 90-degree angle. It needs to be 8. Adjacent means the one that touches theta. So that one is 3. How can I find this other leg? Very good. And you can call it A or B as long as it's a A or a B, not a C, because C is going to be 8. So I can say A squared plus 3 squared equals 8 squared. So A squared plus 9 equals 64. I'm going to subtract 9 on both sides. A squared equals what? 55, right? Square root, and 55, radical 55 will not simplify, so I'm going to leave it at radical 55. Because we're not punching in and get decimals until they tell me to round. So I'm going to leave that radical 55. Okay? So I know cosine. I need to find sine theta. So that means cosecant, right? Sorry, I've done this all day. They already gave us cosine. So the inverse of cosine is secant. Yeah, I can already do that one. It's going to be the reciprocal of 3/8, which is 8 over 3, right? And then I need tangent and cotangent.
I don't understand all that stuff.
What do you understand?
What are those cosine? What is sine and cosine and tangent? What do you find? What does it do?
The opposite over the hypotenuse, or the adjacent over the hypotenuse. It's a ratio of the sides to the angle. It's just a name for it. Don't get caught up in the names. Okay? So sine is always opposite over hypotenuse. So my opposite from theta is what? Radical 55, right? Over the hypotenuse is what? 8. So this is opposite, adjacent, hypotenuse. So this is going to be radical 55 over 8. So this is going to be 8 over radical 55. Right? I know my handwriting's terrible. Y'all good with that? We already found secant. Tangent is opposite over adjacent. So which one's opposite from theta? Radical 55 over which one's adjacent? 3. And so cotangent is 3 over radical 55. That's how you do that. All right, so the next thing we're going to do is solve a triangle. Now, this takes a while. Solve triangle ABC using the diagram. And given measurements. So here's my diagram. Here's triangle ABC. It's generic. Here's A. C is always the right angle. There's B. So the one across from big A is little a. The one across from big B is little b. And big C is little c. And they tell me that the measure of angle A is 54 degrees. and that little c equals 20. We've got to find the measure of angle B, because we already know angle C is 90 degrees, right?
Yeah.
And we've got to find all the other sides.
So B is 36.
So how did you get B is 36?
Add 90.
Very good, because I know this one's 90 and this one's 54. So 180 minus those added together is how much?
36.
Yeah, 36 degrees. Does everybody understand how he got that? He added that plus 90, subtract from 180. So yeah, we got our angles now. So you can just fill it in as you go, 36 degrees. All right, so our hypotenuse is 20. Now, I need to know some side lengths. Well, when I get two side lengths, I can use Pythagorean theorem to get the third. But I've got to use trig to get one of them. So what do y'all want to use? Y'all want to use, let's find little a. So little a, we know 20. So little a to 36 degrees is what? Adjacent, and then here's hypotenuse, right? So let's use cosine. So cosine of 36 degrees equals adjacent over hypotenuse, so a over 20. Now we're going to use our calculators, but we got to check them. First, we got to multiply both sides by 20 to get rid of the 20 in the denominator. That cancels out. So we should be able to type straight in our calculator. Where's my calculator? Now I want you to turn your calculator on. Clear it out. Now we got to make sure we're in degree mode. If you're not in degree mode, it won't work. So hit mode, which is right here beside the yellow key. Hit mode. And mine is in radians. See how where it says radian in degree? Radian is highlighted. So arrow down and go over and highlight the word degree and hit enter. It's a different measure. Miss Durance is going to talk to you about those tomorrow, about degree and radians. All right. So swap it to degree mode, because if you don't do that, it won't work. Okay? And then hit second, quit. If you hit second mode again, it'll quit. It'll take you back to home screen. Second mode, and it takes you back to home screen. Okay, so we're going to hit 20 times cosine, and after the parentheses, we're going to type in 36. 20 times cosine 36. Close your parentheses and hit enter. And that's about 16.2, right? So little a is about 16.2 for that measure. So how do you think we're going to get little b? That's the only thing we like. So I've got all my angle measures, because my angle C was 90 degrees.
We're going to use the A squared.
Yeah, because we're looking for b, right? So we're going to say a squared plus b squared equals c squared. That's hers. So we're going to say 16.2 squared plus b squared equals 20 squared. And I'm going to use my calculator to help me. 16.2 squared, I'm getting about 262.44. That's exactly what it says. Plus b squared equals 20 squared is 400, correct? And then I'm going to subtract that on both sides. So I'm just going to do it in my calculator, not write everything. 400 minus 262.44. I'm getting about 137.56. Did y'all get that for b squared?
Yeah.
So b squared is 137.56. So how do I make it to where it's b and not just b squared equals? What's the opposite of squared?
Little house.
Square root. So I hit second square root in my calculator, and I'm getting about 11.7. B is about 11.7. So solving a triangle, that means you find all your angles and all your sides. Okay? So you can, like I said, if you have two angles, you can subtract from 180. If not, you can do that. Okay. All right, let's do one example of a word problem, and then we're going to call it a day. A flagpole. I should have typed this. I think I'm actually going to copy and paste it because I think I have it. Bear with me just a second because I don't want to write.
We didn't want to.
Thanks. There we go. Copy. Paste. Oh, gotta fix that. Edit. Format text. I'm gonna make it big. Out of 22. Okay, here we go. A flagpole projects a shadow on the ground that is 26 feet long. The angle of elevation is 300. What is the approximate height of the flagpole? So we want to find what the height is of this flagpole. So here we got a flagpole. Let's just make an assumption that flagpole is 90 degrees from the ground, right? There's my flag. Woohoo. Okay? All right. So it has a shadow. Thanks. That is about 26 feet long. So here's my shadow, 26 feet long. Like I said, I'm assuming that's a right angle from the ground. The angle of elevation, that means the angle that line makes with the ground is 300. I think that's supposed to be 30 degrees. Let's assume it's 30 degrees. Okay. Because I think that look big, smaller than the rest of them. Okay, I think it's supposed to be 30 degrees. What is the approximate height of the flagpole? So we're looking. Do what?
26 looks bigger than the 2.
Yeah, I think it's just that font. I'm pretty sure it's this way. All right, so we're looking for the height. Do we know the hypotenuse of this triangle? No. And we can actually work without getting the hypotenuse. And here's how. Here's my angle I'm working off of. Okay? The 30-degree angle. Now, which one? Okay. The 26 is what to that angle?
Adjacent.
Adjacent. Like I said, we don't know the hypotenuse. And so that means this angle that we're looking, this side over here, the height of the flagpole is what?
Yeah.
Opposite. Now, which one of those trig functions uses an opposite and an adjacent? Tangent.
Tangent.
So we're going to say tangent of 30 degrees equals, your angle measure also always goes in here with every.
26 of tangent of 30.
I'm not there yet. Opposite over adjacent. We don't know opposite. I'm going to call it X over adjacent is 26. You're right. So to get rid of the 26 in the denominator, I multiply by 26 on both sides. So it's going to be 26 times tangent of 30 in our calculator.
15.1.
26 times tangent of 30 degrees. 50. Everybody get that? So I'm going to say X is approximately 15 feet. And I'm going to go ahead and do one more with you guys, and we can just kind of talk through it.
We want to find the hypotenuse too?
Nope, we just wanted the height of the flagpole. We didn't care about the hypotenuse. We just wanted the flagpole. Let's do another one. Hang on. This takes a little while. Insert text box. Okay, I'm gonna fix my fonts. Edit text 22. Okay. A hiker stands X feet from the base of a 24-foot tall tree. So here's my tree. There's my tree. Okay? So I'm going to draw a line through the center of my tree. Yeah, it does look like broccoli. All right. So it says a hiker stands. So here's my hiker dude. He's got on hiker boots. I can't draw. So there's a hiker dude with his boots. I'm going to put a ball cap on him. I wear a cap on my head when I go hiking. He needs arms. Okay, here's hiker dude. The hiker stands X feet. So we don't know. We're assuming that the tree is standing straight. X feet from the base of the tree. And he makes, the height of the tree is 24 feet. How far is the hiker from the tree? I'm missing something. It says the angle of elevation to the top of the tree is 45 degrees. So the angle that he's standing from the ground is 45 degrees.
So we're going to use like something other than tangent this time.
I don't know.
Oh, yeah.
Because I don't need to know this, right? I don't need to know hypotenuse.
Yeah, you
So the one that doesn't use hypotenuse is tangent. So I'm going to say tangent of 45 degrees equals opposite over adjacent. So that's going to be 24 over x. Now this one's slightly different. We got to do a little bit more algebra to get this right. First of all, we can't have x in the denominator if we're trying to solve for x. So the first thing we need to do is multiply both sides by x. So then I have x times tangent of 45 equals 24. Not subtract it. What's the opposite of multiplying? Dividing. Good. So then I'm going to divide by tangent of 45. Oops. So that's what I'm going to type in my calculator. 24 divided by tangent 45. So 24 divided by, I'm going to use parentheses because if you don't, sometimes it don't work. Tangent of, not second, tangent, go back. 24 divided by parentheses, tangent 45. I'm going to close parentheses twice. Hit enter. What'd y'all get?
24.
Y'all get exactly 24?
Yeah.
24 feet. So he's standing 24 feet from that tree. But look at that. He's standing the same height as what the tree was. Isn't that so cool? All right. So this is the end of Triggs for today. Have a nice one.